For number 37, we have a system of 3 equations and 3 variables that we need to solve for. So if we look at the equations and all the variables, since we have a z that does not have a coefficient in front of him, z may be the easiest variable to solve for. So what we want to do is eliminate z twice and then use the two variable equations to do elimination again. So I'm going to take the middle equation and multiply him by 4 in order to eliminate him with the top equation. So I have 6x minus 9y plus 4z equals negative 7, and 8x plus 24y minus 4z equals 24. So if we combine this together, we end up with 14x plus 15y equals 17. Now I want to eliminate z again, so I'm going to take the same middle equation, multiply him by 2, and combine him with the bottom equation. So that gives me 4x plus 12y minus 2z equals 12, and then 4x minus 3y plus 2z equals negative 2, and combining those we get 8x plus 9y equals 10. So we are left with the two variable equations, 14x plus 15y equals 17, and 8x plus 9y equals 10. Unfortunately, the coefficients aren't very nice, and it might be difficult to get two of them to be the same. So I am going to eliminate the y's by multiplying the top equation by a 3. So the 15 becomes a 45, and the bottom equation by a negative 5. So the 9 becomes a negative 45. So 3 times 14 is 42x plus 45y, and 17 times 3 is 51. And then I have negative 40x minus 45y equals negative 50. So we end up getting 2x equals 1, so x equals 1/2. From this answer, we can assume that the answer is A, but let's take x and plug them back in just in case. So to find y, I'm going to take x and plug them into one of the two variable equations. So I'm going to use 8x plus 9y equals 10. So I have 8 times 1/2 plus 9y equals 10. So 4 plus 9y equals 10. 9y equals 6. So y equals 2/3. And then finally, we want to take our x and our y and plug him back into one of the 3 variable equations and solve for z. So I'm going to take both of those and plug them into the second equation since the numbers are a little bit smaller. So I have 2 times 1/2 plus 6 times 2/3 minus z equals 6. So 1 plus 4 minus z equals 6. So 5 minus z equals 6. So z equals -1. For our next problem, we want to find the standard form of the equation of this parabola and then find the vertex of the parabola. So since we see that the y is squared, we know that we want our parabola to be in the form y minus k squared equals 4p times x minus h. So what we're going to do is take the x's and the other number and move him to the other side. So we have y squared plus 10y equals 20x minus 37. And now I want to complete the square with the y's. So we have y squared plus 10y, divide by 2 and square it, so we'll add in a 25. And we need to also add 25 in to the other side of the equation. So now we can factor y squared plus 10y plus 25, and we have y plus 5 squared equals 20x minus 12. And it's almost in standard form, but what we want to do is factor out a number, so we have x minus a number in parentheses. So our final equation will be y plus 5 squared equals 20 times x minus 12 over 20 would reduce to 3/5. And there's the standard form of our parabola. To find the vertex, we just use h comma k. So our vertex x value would be 3/5, since that's the value with the x, and -5 with the y. For number 39, we need to do the partial fraction decomposition of 5x plus 3 over x squared minus 3x minus 10. So the first thing we want to do is factor the denominator. So we have 5x plus 3 over x minus 5, x plus 2. So when we break up our fraction, we have a over x minus 5 and b over x plus 2. And now we need to multiply a over x minus 5 by x plus 2 over x plus 2. And we need to multiply b by x minus 5 over x minus 5, because if we were to add these two fractions together, we would need common denominators. So we have a times x plus 2, and we have b times x minus 5. Now this is all over x minus 5 times x plus 2, but we don't necessarily need to write that because we just want our numerators to equal each other. So the denominators are not necessary at this point. So now we are solving for a and b, and we are not solving for x, so we can let x equal whatever we want. So in order to solve for a, I'm going to let x equal 5. So when I plug it in, 5 minus 5 will equal 0, and that will cancel, and I'm just left with my a term. So I have a times 5 plus 2 plus b times 0, and that will equal 5 times 5 plus 3. So I have 7a equals 28. So I know that a equals 4. Now we're going to do the same thing to solve for b, but we're going to let let x equal -2. So a will be multiplied by 0, and we have -2 minus 5 equals 5 times -2 plus 3. So we have -7b equals -7, so b equals 1. And since the a is over x minus 5, for our final answer, we will have 4 over x minus 5. And the b is over x plus 2, so we'll have 1 over x plus 2. So our final answer is D. In number 40, we want to match the inequality with the graph. And since we have a parabola with a dotted line, we know that it must be an inequality without a solid line underneath the inequality symbol. So we either should choose choice C or B. Also, the shading is below the line, so we must have a y is less than symbol. And if we move the y values over to the other side, we can see that B is the right choice because we have y is less than 4x squared. For part B, we want to identify the inequality of y squared over 9 minus x squared over 16. So is less than or equal to 1. So we know that we are definitely dealing with a hyperbola because we have a minus sign in between. And we know that we also have a vertical hyperbola since the y is first. So that would eliminate choices D and B. We know that the vertex is up 3 and down 3 on the y-axis because of the 9. So now we just need to figure out whether this hyperbola would be shaded on the outside of the parabolas or in the middle. So what we can do is we can choose a point and see if that point matches up with our shading. So we can see that in C, 0, 0 is in the shaded area. So I'm going to choose 0 squared over 9 minus 0 squared over 16 and check and see if that's less than or equal to 1. And we see that it is. So C must be the correct choice since 0, 0 is in the shaded area.